Okay, here are the notes for integrated 1, 2.2.2 rate of change. Make sure that your notes are set up. So you've got graph paper, or you have the images sheet that I posted on today's agenda. Make sure you have that in front of you. You're definitely going to want something that will create a straight edge for you. So it's an opportunity to get a ruler out of your backpack or anything that can create a straight line for you. Okay, now that you have your supplies, we're going to go through and take these situations and try to create linear graphs out of them. So we've got our 3 people. The first person we're going to deal with here is Leslie. So make sure that you write down the information that we know about Leslie. Okay, so what we have here is a couple pieces of information. We know that Leslie's going to start or begin at the starting line, okay, and that she wrote at a constant rate. Okay, as soon as I see this rate business, I am going to be thinking of slope. So I do want to take a look at this rate of 2 meters every second. And I want to be able to write that as a fraction like I would with slope. So I'm going to write m equals, it is 2 meters per, so it's creating my fraction, every second. So that is every 1 second. What this allows me to do is have a better idea of what's going to be on my y-axis and what's going to be on my x-axis. As you know, the top of the fraction for slope, so here we'll put this up at the very top for ourselves just as a reminder. We know that slope is going to be the change in y over the change in x. So I should know at this point that my y-axis is going to be meters. So I can take those units to figure out what goes on my y-axis, and then I can take these units from the bottom to figure out what goes on my x-axis. So let's go ahead and do that. So on the bottom, I will have time, specifically in seconds. And then on my y-axis, I will have distance, specifically in meters. Now you can label the increments on here if you would like, but I don't know that it's necessary. I think we're just going to go by ones. So go back to Leslie's situation here. And if she starts at the starting line, then that means no time has elapsed. So the race hasn't started and she hasn't gone anywhere yet. So we're going to put her at the origin. So let's put a dot down at the origin for Leslie. Now I can do the slope. So I'm going to go 2 for my rise and 1 for the run. So I'm going to go up 2, right 1. And let's go ahead and create a dot there. And then I do want to have a very accurate graph for this, so take this opportunity to fill in points all the way across the grid that was given to you. And then do take this opportunity as well to use your straight edge to connect the dots. And then let's label this graph as Leslie. So we know whose it is. Okay. Let's move on to Kristen. So same type of information. However, Kristen got an 8-meter head start. Okay, so that's telling me that her starting value is going to be at the 8-meter mark. I also know that she rode 2 meters every 5 seconds. Okay, so that's my slope. So I know M is equal to 2 meters every or per 5 seconds. Now we still know that the top represents the y, so that's our change in y. We also know that the bottom still represents the change in x. So why don't you see if you can create Kristen's graph? Remember, she's going to get an 8-meter head start. So no time has elapsed, but she's already going to be 8 meters ahead. So keep that in mind when you try to graph this problem. Double check your graph against mine. Notice that I did give Kristen that 8-meter head start. So I went up on my distance axis or my y-axis to where 8 is. And that's where she's going to start. Then I did the slope of up to right 5. Also, use a straight edge to connect the dots. And make sure you label Kristen's graph with her name. Okay, now for Evie, make sure you get her information written down as well. Why don't you see if you can identify what the slope is for her graph and see if you can figure out what her starting value is going to be as well. Okay, so check your slope against mine. I know that she went 5 meters every 4 seconds. And then let's go ahead and graph this one. I see that she has a 6-meter head start. So kind of like Kristen, she got to start before Leslie for some reason. So we're going to go up on the distance axis to 6. And we're going to plot that as her starting point. Then from there, we're going to apply the slope. So let's go through and apply the slope of up 5, right 4, until we're all the way across the grid. Use a straight edge to connect the dots, and then remember to label the graph. Okay, so double check your graph against mine. Make sure that you have Leslie's graph on here clearly identified so we know which one's hers. Same thing with Kristen and Evie. We are going to use this graph a couple of more times. We want to make sure that what we have is accurate. Okay, so what I did here was I copied down the graph that we had created on the previous slide. So you don't have to redraw it. I just drew it so that I could have it here as well. Okay, so what I would like us to do, and you can use your work from the previous slide, I would like us to write the equations for each of these riders. So down at the very bottom, underneath this graph, I'm going to go ahead and leave a spot for us to write Leslie's equation, Kristen's equation, and Evie's equation. And I want you to use what we did on the previous slide, or you can take a look at the graphs here. I I want you to see if you can write Leslie's equation first. Okay, double check yours against mine. I did go ahead and write the one denominator for the slope. You'll also see that I got rid of the units, the meters and the seconds. They're not necessary in the equation. I also have a 0 for my starting value or my y-intercept. But we can clean this up a little bit more. You don't have to have the 1 underneath the 2. We do need the x for sure, but we don't need the plus 0. So I think here we have Leslie's equation. So y equals 2x. I want you to see if you can write Kristen's now. Okay, double check yours against mine. There is no cleaning up when it comes to Kristen's. We definitely want to get rid of the meters in the second. Those aren't necessary for the equation. But it's not like we can drop the plus 8 like we did with the 0. And we definitely need both the 2 and the 5 for her slope. So I think that's her equation. All right, now let's try EVs and then see if we can answer some of the questions on this page. Okay, so check Evie's equation that you got against mine. You notice that we still have the slope, got rid of the units, and we do have y equals, and don't forget that we have that starting value of 6, the fact that she got a head start. Okay, so now let's take a look at the questions on this page. So looking at the graph and having the equations, we want to take a look and see. So we're trying to figure out some time frames here. So after how many seconds? All right, so I know that for the seconds here, I'm going to be taking a look at the x-axis. So I need x-axis information because that's where the time is located. So x-axis information. Now, let's take a look at what the question says. So we want to know when Leslie and Evie were at the same location in the race. So let's take a look at our graph, and we want to know Leslie and Evie. So it's so important for us to make sure that we labeled our graph earlier. So if we take a look, we want to find out where Leslie, my orange graph, and Evie, my purple graph, are at the exact same location. So I want to find where their two graphs are going to intersect each other. So if I take a look at it, it looks like they intersect. I'm going to put a red dot where they both intersect. So where orange and purple come together. Okay. But what I care about here is the seconds, not the distance, just the seconds. So I'm going to take that and I'm going to go straight down to the x-axis to try to figure out what that is. So counting from the origin, the blue boxes, so 1, 2, 3, 4, 5, 6, 7, 8. So I would say that they are at the same location at 8 seconds. So 8 seconds into the race. Leslie and Evie are tied. So they're at the same location. Okay, now let's take a look at this part C. I'm going to move it up so we have a little bit more room. So the race was 20 meters long. All right, so we need to go up to where 20 meters would have been. I think I'm going to put a dark blue, well, not blue, because there's already a whole bunch of blue on there. Let's do yellow. So I need to count up on my y-axis until I get to 20. So let's take that minute, count up to 20, and then we're going to run a line straight across at 20. So we realize that that's where this thing is over. Okay, so I counted up to 20 and I ran that line across. If this is the finish line, basically to try to figure out who won, we want to know which person in the race, Leslie, Evie, or Kristen, got to that yellow line the fastest. So in the least amount of time. Well, if I take a look at it, it looks like Kristen is still going. So I think the question is either, is it going to be Leslie or is it going to be Evie? So let's take where Leslie is with that line and let's figure out how many seconds that took her. And if this is 2 past 8, so it looks like 10. So it took Leslie 10 seconds to finish the race. Let's see how long it took Evie. So Evie, right where her purple line hits the yellow, well, it looks like it's definitely after. So I don't know, I would say like 11 and a quarter maybe? Well, as far as I'm concerned, it looks, definitely the 10-second mark was faster. So the person who won would have been Leslie. And I'm going to say she finished the race in the least amount of time. Okay, so moving on to question number 2. Now we have more competitors have joined the big race. This is heat number 2. So the information that is given to us here is in a different format. So we have Kay was given an equation, Elizabeth also given an equation, and then Hannah, we got a table. So we want to try to answer a couple of questions here based off of their information. So take this moment to make sure that you get this information written down for each of these writers. Okay, let's take a look at Kay's information first. And I have a couple questions for you. So for Kay specifically, we want to know how fast is she writing? Okay, well, we know that her speed or the rate at which she was traveling, if we think back to the big race we did just a minute ago, would have been the slope. So I want to identify the slope from her equation. Remember, m is so use our correct terminology here, it is the coefficient, so the number attached to x. So in this case, it's going to be 2/3. But I want to get some context in here because if somebody asks you, well, how fast was that person writing? And you say 2/3, that doesn't really mean anything. So we want to put those units back on to the top and the bottom of the fraction. So if we think back to where we started with this, we know that it was meters on top and it was seconds on the bottom. So what we could say is that K is writing at a rate of 2 meters every 3 seconds. So 2 meters every 3 seconds. Okay, so that was one of the questions that we wanted to know. Another question that I want to know is, did she get a head start? So did Kay get a head start? Remember, this information is going to come from her starting value or her y-intercept. So if I take a look back at that, yeah, it looks like she did. Because b in the equation was positive 1, this is telling me that she got a 1 meter head start. So I would say yes. Okay, got a 1 meter head start. I want you to take these questions and answer them for Elizabeth as well. So by looking at the slope, I was able to identify that she was riding at a rate of 12 meters every 16 seconds. But I wonder if this can be simplified. So I'm going to take a look back at Elizabeth's equation and see if I can simplify the 12 over 16, which I think I can. I can divide both of those by 4 evenly. So that's going to give me 3 over 4. Okay, so let's rewrite this then. So I would say Elizabeth is riding at a rate of 3 meters on the top every 4 seconds on the bottom. Go ahead and see if Elizabeth got a head start or not. And if she did, write down what it is. So based off of the B value, which is 4, I know that Elizabeth got a 4 meter head start on this. Now with Hannah, what I'd like you to do is figure out the rate that she is riding. I'm not so concerned about whether or not she got a head start, but I do want to know how fast she's going. So let's see, what is Hannah's speed or rate? So remember, that's slope. So why don't you see from the table if you can figure out what the slope is going to be? So I think what I would do is I would go back to the table and I would try to treat this like we did recently when we were given 2 points and we wanted to find the slope. The thing that makes this a little tricky is we have more than 2 points, but that's okay. I'm just going to pick the 2 points that I like the best because as we know, it doesn't matter what points you use, you're going to get the same slope on one single line. So I'm going to choose the first 2 points only because they're smaller. And I'm going to write those out for myself as 14, 10, just because I like to identify my x and my y's. 28, comma 14. So now the first x value I'm going to call x1, and the first y value I'll call y1. Second x value, second y value. Now I'm going to go back to what we did previously to find the slope. I'm going to use my formula, which I know is the second y minus the first y over the second x minus the first x. Now I'm just going to plug in stuff where it goes. So 14 minus 10 and 28 minus 14. If I subtract those, I'll get 4 on the top. Don't have a problem with that subtraction at all. And then I will get 14 on the bottom. I am going to simplify that though. 2 goes into both of those evenly. Now that's her slope, but I need to identify it as her speed. So I would say Hannah is writing at a rate of 2 meters every 7 seconds. And that'll finish up our notes for 2.2.2.